All right, let's do a few more applications with Venn diagrams and sets. And we're going to talk mainly about surveys today. And one thing I want to remind everybody, in case it wasn't clear in the other videos, because we didn't do too much with the words, is that when you see that word or, you want to think about unions. When you see that word and, you want to think about intersection. So something is in both sets. And when you see that word not, you want to think about complement. So when we're reading things, in word form, we tend to use words like or, and, not, rather than union, intersection, complement. So we have to change that in our brains in order to interpret the Venn diagram correctly, right? Or interpret the set rules correctly. So let's do a couple examples with our surveys. So we're going back to that same example of would you be willing to donate blood or serve those breakfasts who do donate? So the two questions that were asked as a reminder were, would you be willing to donate blood? And would you be willing to help serve a free breakfast to blood donors? So we're going to let A be the set that represents students willing to donate blood. And we're going to let B be the set that represents students who are willing to help serve breakfast to donors. And then the survey results are summarized right here in the table. Now, I'm just going to make a little note for myself that A were those who are willing to donate blood, and B are those who are willing to serve breakfast. Now, you don't have to do this. I think for me, it's just going to make it a lot easier to keep straight what A is and what B is, and then I'll be able to answer the questions faster. So they're telling us that, we have our different parts that we're used to here. So we have some that are in both groups we talked about last time. So the middle piece are students who are willing to do both. They're willing to donate blood and they're willing to help serve breakfast. Whereas in the lighter blue sections, those are students in either set A or B who are in just that set alone. They're not in the both category. And then you have 290 other students who are on the outside here. So these would be students who are not willing to donate blood and they're not willing to serve breakfast. So they do not want to be involved with the blood drive. All right, so let's use the diagram to answer questions. How many students are willing to donate blood? So donate blood refers to part A here. So I want all values in part A. So notice I have 370 and then also 120, right? So this whole group here is A. So I have 370 plus 120. So I have 490 students who are willing to donate blood. How many students are willing to help serve free breakfast to blood donors? Well, free breakfast refers to set B, right? So we're looking at this set here. So how many people are willing to help serve breakfast? 120 plus 220. Now, these could be the same people, right? We're not talking about unique people. Some of these people are giving blood and they're serving breakfast, but we just need to know, well, how many people are willing to serve, to donate blood? How many people are willing to help serve breakfast, right? It could be the same, some of the same people. So we have 340 people there. How many students are willing to donate blood and serve breakfast? Now here's your and word. And means intersection. So we want the two, these people are going to be in both groups. So they're going to be that middle piece, that intersection piece. So they're donating blood and they're serving breakfast. So that's this group right here. So that right there, that's your intersection. So we have 120 students who are willing to do both. How many students are willing to donate blood or serve breakfast? Now that word or means union. So this part here, part D, is actually asking us to find a union B, right? We want both of these together. Now think about this. For A, I have the 370, I have the 120, and then for B, I have the 120 and I have the 220. But I don't need to write that 120 twice. Remember, we don't want to double count when we're doing sets or have repeats. So when I'm combining A and B together, we need to be careful here that we're not including that intersection twice. So this is one way to do it, is to visually just find that union, right? We're combining those two sets together. So we're going to add this all up. And we have 710 students. Right? So those are 710 unique students. Now you could also do this using the cardinality rule we talked about a few videos ago. So the number of units in so the number of units from A was 490. The number of people from set B, or units or elements here, was 340. And then the number in the intersection was 120. So this is another way you can do it too. If you add that 490 and the 340, we get 830, and 830 minus 120 will give you that 710. So there's two different ways that you can think about it here. You can use your Venn diagram, and just remember that with unions, we write both sets, but we don't repeat. And that's kind of how I did it here. Or you can use that cardinality rule that we talked about a few videos ago for unions. And remember that in this case, you add the two full sets, but you subtract the intersection so that that intersection doesn't get counted twice. That's why we're subtracting the intersection. So it's already been counted previously. All right, for E, how many students are willing to donate blood but not serve breakfast? So your E group is this one right here. So these are students who will donate blood, but they're not going to serve breakfast. So they're not in the intersection here with B. And then the other idea, how many students are willing to serve breakfast but not donate blood? So that, again, that's this group over here. This group is willing to serve breakfast, but they don't want to donate blood. How many students are neither willing to donate blood nor serve breakfast? So this is a double, right? You have complements here, right? We're not donating blood and we're not serving breakfast. So it's the complement of A union B. So there's 290 students here who are not willing to do either, right? So there's 290 here that are outside both of these sets. So that would be answer G here. And then finally for H, how many students were surveyed? Well, we can figure that out. We just have to add everything up. So we can do it a few different ways. One way that's the easiest is to just add each of the unique regions. So we could add that 370, the 120, the 220, and then the 290. Another way to do is also take what you already know, and then from the union here, and then you can just add the 290 to it. That works as well. So let's see, we have 16, 17, 18, 19, 20. So 5, 6, 7, 8, 9, 10. So I have 1,000. And you can see that you can also do that from the 710, from the union, and then the extra 290 that don't want to participate also get that 1,000. Okay, so 1,000 students in total were surveyed. Now you can take this further. If you want to actually write down what the set notation means for all of these, you can do that. So we kind of did a little bit on some of them, right? So we talked about how this is the intersection. We talked about for part D, how we're actually looking for the union here. I kind of mentioned for F that we're talking about, for G that we're talking about complements. So if you want to write down all that set notation, you can, but if we're using the Venn diagram, we can really just figure it out without having to overcomplicate it, right? By using that picture to help us see the overlapping regions.